Alright, welcome back. Once again, we're continuing adding code to our array of games. I realized that the last few videos I have not updated the version number, so I'm going to keep in sync with my slides that I showed at the first video. In this multi-part video I had different versions, and version 5 was where we're going to work on the ASCII character part of the game. So we want to now implement where it says the play. We want to actually be able to implement that. Now I'm going to pull up the ASCII character table. You can go to this website, ASCIItable.com, and here's the table. It's a great example of an array because notice if you look at this column starting at 0, each number as it increments is a particular character. Now the characters that are in red are what are called non-printable characters. So these have different control codes that go. For example, one we've been using throughout the class. Notice this line feed right here, decimal 10 line feed, and also the decimal 13 carriage return. Well, it turns out when we do a line feed, this number 10 LF, that's actually what happens when we send a new line character when we send a new line character, it actually sends a 10, which is called LF, line feed. So Linux, the C language \n calls it a new line. Here the ASCII character is 10, which is LF, line feed. Right? And notice even right here they say new line. So that's where that comes from. So the first, starting at 0, you go all the way up. Notice all the way up to 32. Or if you prefer to do it in hex 20. Up until there, it's non-printable. In fact, hex 20 is the first printable character in that it's a space. Right, so we have a space. And as you go on up, for example, the numbers right here, starting at hex 30, or decimal 48, I typically remember it as hex. So hex 30 is 0, 1, 2, 3, and so forth. So this is a great example of an array. And in fact, here's what we want our program to do. Going from 0 to 127, our program is going to display a number, and you're supposed to answer what character is it? What character is it? Now when you think about it, we got all these non-printable characters, and one way we could do it is say you need to type in, for example, LF if it's a non-printable character. To simplify it for the sake of this, because if you can do a little, you can do them all, I'm actually only going to focus on the digits, the 0 through 9. And since I find in my own work I've done it mostly in hex, we'll display the hex number. So our program will say like hex 30, what is the ASCII character? And in that case it'd be 0. Or hex 39, well that would be 9 here. So you could do the whole thing, but we're going to do just this table. Alright, with that in mind, here we go. Inside our ASCII C, make sure I'm in the right file. Pardon me, ANSI. ANSI. Gosh, got this spelled wrong now. So ASCII. Okay. So ASCII Char Game. American Standard Code for Information Interchange. Okay, I got it here. It's our ASCII character. Now, I said the array is actually 128 characters, but for our purpose, static, meaning we'll keep it private here to us. We're going to have a static, this will be an array of characters, because we want to know what character it is. And our array is going to be, I'll say ASCII table. And we actually know it's going to be 128 entries. Why 128? Well, I go over here. This is 0 all the way up to 127. So 0 through 127, that's 128 entries. And again, just to make it clear, we'll go ahead and set them all to 0. So by default, we have all 128 of these set to 0. Now, when it comes time to play the game, the first thing we want to do is initialize our ASCII table. So what I'll do is say ASCII, I'll just call it init table. And that function, I'll put that function, maybe I'll put it right here after the table, void init table. And I do not want anybody to call this other than right here, so I put static in front of it. Right? It hides it. It says nobody else can call this. This prevents in the future anyone trying to call this. And what we're going to do is say our ASCII table at hex 30. Notice I'm actually indexing. In fact, I'll do it both ways. I could say, let me go back to my table. Right here, since I only want to do with these digits, 0 through 9, at 48 is 0. So I could say at 48 is this character 0, right? And I could say also the ASCII table at 49 is 1. And just to give us some experience using hex, I could say ASCII table of hex 32 equals a 2. An ASCII table using hexadecimal. Hexadecimal, you go, the reason I do it in hex, you can see it's pretty easy to remember. 32 is a 2, 33 would be a 3, and so forth. Right, so we can initialize them like that. So here it is in decimal, here it is in hex. So decimal, you count from 0 to 9. We're familiar with that because we have 10 fingers. In fact, that's why we're so familiar with decimal, we have 10 fingers. If we had 16 fingers, yeah, we'd be in hexadecimal, and we go from 0 to F. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. That's hexadecimal. So that's why hex 32. The convention is you put 0x in front of the number, and the compiler says that it's hexadecimal. So what I can do is, just to give us experience with the array, I'll say, well, we're going to just increment this. We got, right, that would be the 4. And interestingly enough, I'm going to do this as well. It turns out we could say, actually, I think what I'll do, just to make this simple, I'll copy all 3 of these in hex that I've already got. I copy those into my buffer. I'll paste them here. And of course, you got to be real careful, right, when you do this, because when you paste, make sure you have the 35, the 36, the 37. Right, so we have 5, 6, and 7. And we just need 2 more, right? 8 and 9. So go ahead and put 2 more. We'll have, this will be the 8, and this will be 9. 8 and 9. So we've initialized at least the part of the table we're interested in, right? So what we'll need to do, we've initialized the table. We took care of that. And what we'll do is randomly pick a number out of here and display it. And we'll do it in hex, since that's the, we'll say hex 34, what digit is that? And you'd have to enter the digit. So we've initialized the table. I would say next, let's get our, let's get the number we want to guess, right? We know it's going to be one of these. So we need really a random number. So I'll say integer choice is going to equal to, well, before we do that, and this is a case where, you know I need a random number, so I'll just say choice, I'll say answer equals, I'll say random get random index. All right, we know we're going to get a random index, and again, this will be a function inside only this file. So static, right, make it private, static, it's going to return an integer, get random index. And I know I need to do that, but I'm so eager to try something. For right now, I'll just return, oh, let's pick about hex 35. Right, that'll be the one just for the purpose of this one. And then we'll say while, we'll do the while, let's do this. We'll say do while and some condition. Well, the condition will be while we're playing. So we'll say integer while playing equals 1. So 1 is true. So while we're playing, keep doing this. Do this while we're playing. So we've displayed the table. Actually, we've initialized the table. And we'll say, right, we'll say, okay, we got the choice. Right, we got the answer. I think what I'll do is say printf ASCII value of 0x %x is what? Is what? All right. I'll say is what char. All right, we'll print that out. Of course, here, what we're going to put is the answer, whatever answer came back. And then here, we will get your choice. We want to get your answer, so we'll say integer. We'll give your choice that you've read, and what we'll do is say scanf a %c, because we're looking for a character, giving it a pointer to where the choice is at. Oh, and notice it's just giving me a warning. It's saying format specifies a character pointer, but the argument is an int pointer. Ah, okay. Well, we'll make it a character then. So we'll scan in the choice. If the choice that you entered is exactly equal to the ASCII table using our answer. So if that's true, then we've picked the right one, and we'll say printf correct \n. And if that's true, we'll say playing equals 0, because right, you're no longer playing. And the else condition will be printf try again. Now I think we may have to refine this a little bit, but it's kind of a good step to see what we've got at this point. I'll go ahead and click run, see if we have any syntax errors or anything. Well, so far so good. But wait a minute. If I say I want to play this game, if I type a 0, oh, it says to do, handle the game. So actually we need to modify our play function so that it actually calls this ASCII character play. So we can do that. Go to play.c, and right here, after we've made our choice, notice right here we had this handle the game. Whereas now what we want to do is a switch statement based on our choice. And if we do a 0, we're going to do, remember how we initialized this, the 0 was this guy. So what I'll do is go to my header file, copy this, go back to my play.c. Remember, you can pause the video if I'm going too fast on this. We want to call that, and then we'll break out of here. So that's if we have case 0. Right, that'll be case 0. If we have case 1, then what you have picked then is this ASCII game. So I go to my ASCII play, come back to my play.c, paste that one, and then the final case is going to be the tic-tac-toe. So I'll grab tic-tac-toe play, go over here to the play.c, and say we'll do tic-tac-toe. Alright, those are my choices. So I'm either going to exit, or I'm going to get one of these. This would be case 2. Let's see what we got. Click on run. Alright, let's choose 0. Press enter. Ooh! ASCII value of hex 35. And notice I got to try again. Well, wait a minute. That didn't seem right. What? Why? What happened there? Why did I say? I mean, this part was right, but it never gave me a chance. It said try again. Of course, we said that this is a 5, so if I enter a 5 and press enter, correct. So the question is, why did we get this try again? And we've seen this before. It's a little tricky. Remember when let's go back to our ASCII game, pardon me, the ASCII character game. This scanf scans a single character. It makes this check and spins around and checks again. Well, now there's a new line, because remember, when you type a character, we also press the new line. So it turns out this was getting the new line as well. So when we came in here, it got the first character, and then what we should have done, instead of having it come around and say this try again, we should have also, I'm going to call eat the new line character. So we'll just once again call this scan, because this will always be a new line character as well. So we'll click on stop, click on run. We'll do 0. let's say it's instead of it's well, first let's check out. We know we can have a 5. Oh, wait a minute. We got the try again once again. That's not what I was wanting. Wait a minute. I thought here it should have taken care of it, right? It should have eaten it, come around. So let's click on stop. Let's run it again. When I press enter here, this is an enter. Boom. So right now there's an enter. It reads the enter, and then it's saying try again. So this is where it gets tricky. So what happened, actually our menu, when we displayed the menu, we were leaving an extra new line character there. Kind of tricky, isn't it? So go back to the play.c where we displayed we said select this, right? We said right here where we got your menu choice. Well, we should also eat the carriage return. Eat the new line. So I'll do a scan F of a %C. And actually looking at it here, notice since these are just going to be 0, 1, and 2, although we can also enter a -1. So what I'm going to go do is have a integer, I'll just call it C, a pointer to C. So this will eat the new line character. So %C, let's see what we're getting here. It says format specifies a character pointer, but the argument is an int pointer. Oh yeah, this should be a character. All right, let's run it. Okay, I want to do 0. Cool. ASCII value of 35. Okay, well I know that's decimal 5. Correct. We did it. Let's test it again. Let's check the wrong answer. If I said it was a 2, which we know it's not, try again. It's a 4. Try again. It's a 5. Correct. Now you could clean up this output a little bit, but this is good for now. And our key is to be talking about arrays. Now, in an earlier video, I put a random number generator to randomly pick. Due to time, since I'm focused on arrays on this, I'll leave the random number generator at least out for now. But for this video, get it where at least you have this one case, because in our game, we've now got experience of having an array of an ASCII table, going ahead and initializing it, initializing some part of the array, and here you could get a random index, right? You could go ahead and get a random index if you wanted to out of there. In fact, gosh, we're so close, why don't we do it? We could say srand of, let's get the current time. So srand means seed, the random number. All right. Notice implicit declaration, it doesn't know where this comes from. Let's go ahead and say, well, we could look it up, right? We could Google it, or let's see, just out of curiosity, let's see if we can remember uni standard. The reason I'm doing it like this instead of Googling it and looking it up is unistandard is pretty common. Well, that didn't do it. Right? It wasn't there. Another one that's pretty common, if unistandard, standard lib. Still no good. In fact, that says too few. Oh, actually, that is good. Notice it says too few arguments. So now it does know about it. It says too few arguments. It's expecting us to give it a seed value. in here. So what we need to do, we will call time, passing in the value of null. And actually, to break this up, we know if we're going to use time, we need to include time.h. Right, we've done this in a previous video. So time.h. Now I'll say we're going to have a time type called now equals, go to the time function, pass in null, that'll return the current time, and then we will give a pointer to now and make that our seed value. Now notice it's giving me a warning, it says incompatible pointer to integer conversion. So here it's incompatible pointer to integer conversion. So looks like actually I could just say sRandom now. So that initializes the random number. Now to actually get the random number, I'm going to say choice equals 2. Let's do rand. So that'll give us a random number, but we're going to divide it by 10. Why 10? Because we want to go from 0 to 9. So that will give us basically 0 through 9. Well, remember, this gives us the remainder. So we're dividing by 10, so the remainder is going to be either 0 remainder all the way up to 9 remainder. And so then I'll return the choice. Let's see what we got. So I run. I want to do this one. Ooh, what's the value of, wait a minute. Isn't this cool? I mean, this is one of the things I enjoy about coding is that you find you've made an error, right? We made a logic error. And that all of our numbers, this random number, is always offset. Since we're only dealing with the 10 digits, we should offset this by hex 30. And this is where comments, since we are only using digits 0 through 9, we offset the random number by hex 30. So I'm going to say hex 30 plus the choice. In other words, whatever choice we got, although the choices go from 0 to 9, we want to start at hex 30, which is character, the 0 digit. Alright, let's run it. Okay, we'll do this game. Ooh, 37. Now that looks right. Well, that's 7. Correct. Alright. Let's do it again. ASCII character game. Ooh, let's give a wrong answer. 3. Try again. Oh, well, 0. Correct. Alright, got it. Now there's clearly we could make this game a little more, but I think you've got the core concept. Feel free to, if you want to implement the whole thing. But here if you just get digits 0 through 9, you'll be good. Okay, as always, make sure your code is matching this. I'm Norman McIntyre. Thanks as always for watching.